All right, well, hello again, my 8th grade friends. And we are continuing with solving systems of linear equations. But today, the focus is going to be on multiplying first and then eliminating. So we have 4 examples that we're going to go through here on this video. And this video here, which is for Thursday, May the 14th, just so you know, is also what is connected with Monday, May the 18th. So you may want to come back and revisit this video on Monday, May 18, as there's kind of a part 1 and part 2. Solve the linear system by multiplying first and eliminating. So here's our linear system. 4x plus 3y equals 8, x minus 2y equals 13. And your work is going to need to show evidence that you understand the multiplication method. So when I look here, I'm looking at x and 4x, 2y and 3y, and I'm looking for a way to get something the same so that I can eliminate. And so when I look at this one, I'm like, well, here's 1x, here's 4x. If I were to multiply this by 1, or sorry, not by 1, if I was to take this 1 and multiply it by 4, 1 times 4 would give me 4. So all I'm going to do is I'm going to take this particular equation and I'm going to multiply it all by 4. So I'm going to keep my 4x plus 3y equals 8. So 4x plus 3y equals 8. That's going to stay the same. I'm going to multiply this by 4. Well, 4 times x is 4x. 4 times a negative 2y is a negative 8y. And then 4 times 13 will be 52. All right, everything's all going to be lined up for you. And now I'm going to eliminate. And I can see by looking at this, I'm going to have to eliminate by subtraction because it's 4x minus 4x that gives me nothing. So I'm going to put my line underneath as we have been doing. 4x minus 4x is nothing. So now I'm at 3 minus a negative 8. 3 minus a negative 8. Well, 3 minus a negative 8 is like 3 plus 8, so that actually is going to give me 11y. And then I'm going to have 8 minus 52. If you plug that into your calculator, you're going to find that that equals a negative 44. Well, if 11y equals a negative 44, I'm stuck with negative 44 divided by 11. Negative 44 divided by 11 tells me that y equals negative 4. So now I can just take my y equals negative 4 and plug it into one of my equations up here. I'm going to go ahead and use this first equation, 4x plus 3y equals 8, because now remember what I want to do. I need to find the x coordinate because it's still solving linear equations. It is still finding the intersection point between the two lines. So I'm going to set this up now. I'm going to keep my 4x the same. 4x plus 3y. Well, 3 times y, if y is negative 4, 3 times negative 4 is negative 12. When I add a negative 12, that's just minus 12. Okay, and so then that whole thing is going to equal 8 from my top equation. So now I want to solve for x by adding 12 to both sides. So I'm going to come over here and do 8 plus 12. That's going to give me 20. So I'm left with 4x equals 20. And if 4x equals 20, I'm going to do 20 divided by 4, x equals 5. And that tells me that x equals 5, y equals negative 4. My ordered pair is 5, negative 4. All right, so we're looking at this next one. 11x minus 20y equals 28. 3x plus 4y equals 36. Well, I'm thinking, well, if I were to multiply this 4 by 5, that would give me 20. So I'm going to go ahead and I'm going to multiply this whole thing by 5. All right, so it looks like I'm going to give a little division line here to keep everything separated. My 11x minus 20y equals 28 is going to stay the same. So 11x minus 20y equals 28. That's going to stay the same. I multiply this whole thing by 5. 5 times 3x, that is 15x. 5 times 4y is going to give me a plus 20y. And 5 times 36 is going to make that whole thing equal 180. All right, well, okay. So now I need to see how I'm going to eliminate. Clearly, I'm going to be working with the negative 20y and the plus 20y. And I'm just going to add. Negative 20 plus 20 is 0. All right, so I'm just going to be adding. So this is 11x plus 15x, which equals 26x. If I do 28 plus 180, I find that that equals 208. And if I were to go into my calculator and punch in 208 divided by 26, I would find that for sure x would equal 8. It's amazing how it works out. So now all I'm going to do is I'm going to take x equals 8 and I'm going to plug it into my first formula here. And so I'm going to do 11 times 8, since x is 8, and 11 times 8 is 88. So it's going to be 88 minus 20y equals 28. And so that's what I'm left with. Now, how am I going to figure this out? Well, I'm going to have to subtract 88 from both sides. That's going to give me 0. If I come over here and subtract 88, that's going to give me negative 60. 28 minus 88 equals negative 60. So I'm left with negative 20y equals negative 60. Well, negative 60 divided by negative 20 is 3. So y equals 3. And I find that my ordered pair for my intersection point is 8, 3. X is 8 and 3. All right, so that's pretty straightforward. These next two are not quite as straightforward, because if I look at this example, 7x minus 6y equals negative 1, 5x minus 4y equals 1, I can't really take the 5 and turn it into 7 or vice versa. I can't take the 4 and turn it into a 6 or vice versa like we were able to on the first two. So in these last two examples, these are examples where both equations have to change. So what I'm going to be looking for is common multiples, all right? And I want to try to work with as small a numbers as I possibly can. And so I could think about 7 and 5, and 35 would work. But if I were to use 35, I'd be multiplying this whole thing by 5, because 7 times 5 is 35. And I would be multiplying this entire equation by 7, because 5 times 7 is what makes 35. But when I look at my negative 6 and my negative 4, or if I'm just thinking about it as 6 and 4, I'm thinking that, well, both of those can go into 12. 12 is a multiple of both of them. And so I can multiply this whole equation by 2 to make that a 12. And I can multiply this whole equation by 3 to make that one a 12. All right? So now I'm saying, well, 2 times 7x is 14x. 2 times a negative 6y is a negative 12y. And then that's going to equal 2 times negative 1, which is negative 2. And then if I multiply this second equation by 3, 3 times 5x is 15x. 3 times a negative 4 is a negative 12y. And now you can see how it's going to work to eliminate, because we're going to be able to cancel that out. And then 3 times 1 is equal to 3. So let's think about what we're doing. We have negative 12 and we need to get to 0. So really what we're doing is we're subtracting a negative number. Negative 12 minus negative 12 is like negative 12 plus 12. So we would get 0. So really what we're doing, and I want to make it very clear, what we're doing here is subtracting, because it's negative 12 minus a negative 12 to make 0. So that cancels out. So I go ahead and put my line. I know I'm subtracting. 14 minus 15 is negative 1. We don't put a 1 in front of the x, so we get negative x. Negative 2 minus 3 equals negative 5, and I don't want negative x, okay? So I'm going to multiply everything by a negative 1 to change the signs, and that's going to tell me that x equals 5. And so now I can just go back into one of my original equations, all right? I'm going to look at 5x minus 4y equals 1. All right, that was one of my original equations, and I'm going to go in and plug in 5 for x. Well, 5 times 5 is 25. So that leaves me with 25 minus 4y equals 1. Well, I'm going to go ahead and I'm going to subtract 25 from both sides. That's going to give me 0. When I come over here and I do 1 minus 25, that's going to give me a negative 24. And that leaves me with negative 4y equals negative 24. If negative 4y equals negative 24, I know I'm just doing negative 24 divided by negative 4. That's going to tell me that y equals 6. My ordered pair is 5, 6. X equals 5, y equals 6. All right, we have one more example that we're looking at here. We're starting with 7x plus 3y equals negative 12. 2x plus 5y equals 38. All right, so we want to think, well, what do we want to do? All right, well, there's a variety of different things that we can do. I'm looking at 7 and 2, and I can make that work with 14. I'm looking at 3 and 5, and I can make that work with 15. Let's see. We made the y's the same in the previous example. Let's go ahead and make the x's the same. So we're going to make these both 14. This first equation is going to become 14 with the 7x by multiplying it by 2, because 2 times 7 is 14. The 2x is going to become 14 by multiplying it by 7, because it's 7 times 2, that's 14. So now we're going to rewrite our equations. 2 times 7x is 14x. 2 times a plus 3y is a plus 6y. 2 times negative 12, that whole thing is going to equal negative 24. Now if I take this entire equation and we're to multiply it by 7, 7 times 2x is 14x. 7 times a plus 5y is going to be a positive 35y. And 7 times 38 is going to equal 266. 38 times 7 is 266. Now, I see once again that I'm going to have to subtract, just like I did in the third example, because it's going to be 14 minus 14 that gives me 0. So cross that out, and I'm going to be subtracting. First, it's going to be 6 minus a positive 35, just 6 minus 35. That's going to give me a negative 29y. Then I'm going to do negative 24 minus 266. Negative 24 minus 266. And once again, 8th graders, pretty much all the time, like Mr. Swack tells you, it's amazing how the numbers work out. Because negative 24 minus 266 equals a negative 290. And that seems like it's going to work out just fine, because when I take a negative 290 and I divide that by negative 29, I find that y equals 10. Now I want to go back and plug in 10 to one of my equations, and I'm just going to plug it in to this first equation. 7x plus 3y equals 12. Well, I know my 7x is not going to change. And then if I do plus 3y, well, 3 times y, if y is 10, 3 times 10 is 30. So this is going to be plus 30, and that whole thing is going to equal negative 12. Well, if I want to isolate the 7x, I'm going to subtract 30 from both sides. And negative 12 minus 30 is going to give me, oh boy, negative 42. No, wasn't quite sure how to get that 4 in there. So now I'm at 7x equals negative 42. And if 7x equals negative 42, I'm just taking negative 42 and dividing it by 7. Negative 42 divided by 7 equals negative 6. x equals negative 6. X is negative 6. Y is positive 10. My ordered pair is negative 6, 10. All right. We'll talk to you later, 8th grade. Bye.